Good morning, everyone. I'm Qudar Abdul Karim from the School of Engineering in APU, and I'd like to welcome the panel to my VIVA presentation about my final year project, Energy Harvesting from the Human Body. The agenda for the presentation is shown in the table. There will be 14 sections in total explaining the FYP. There are many problems with the current state of energy harvesting. First one being not enough power from one source. Since each source will harvest so little power, it is necessary to put multiple sources to harvest power as much as possible. Secondly, durability and washability. The device should work 24 hours and it will go through hard conditions, especially on the washability side since it will be exposed to water. Thirdly, voltage boosting not sufficient. The power harvested will be little. In order to use it to power up low-powered microcontrollers and sensors, it needs to be boosted to a proper voltage. Lastly, use of one-dimensional movement. Most harvesters use one-dimensional movement harvester. A solution for that, three-dimensional movement harvester, where the hand of the user will move in a 3D space and will harvest the power in each move. The aim and objective for the project. The aim is to develop a mechanism to harvest the human motion by using electromagnetic generator. Next is harvesting the heat, and the device will be housed for a human rest. The objectives are, firstly, to develop a thermoelectric generator. Secondly, to develop a motion harvesting device. And lastly, is to evaluate the system in terms of its efficiency. Moving on to the literature review. 15 journals were studied and summarized in the table here. The first two is about sensors that can be used for the system. The first one is the temperature sensor, where the user can sense his temperature throughout the day. The second one is the heartbeat sensor. Patients can use this system to monitor their heartbeat throughout the day. The third and fourth and fifth journals talk about the harvesting method, where the fourth one and the fifth one is about the thermo harvesting method using thermoelectric generators. The first one is about the kinetic energy harvesting for the human movement. Journal 6 to 10 talks about the energy harvesting method. It has been observed that the best method for harvesting heat is the thermoelectric plates or the Partier modules. And the movement harvester can be done with coils and magnets inside of them. Journal 11 to 15 talk about what ultimately the system is, which is a self-powered device. Journal 11, 14, 15 talk about an IoT system for a self-powered device, where a microcontroller with Wi-Fi modules will be powered through the system to send the data through the internet. Journal 12 and 13 talk about sensors and their microcontrollers, which are a low-powered microcontroller to be powered through the system. The block diagram for the system. The system will start by the user wearing the device. The heat will be transferred to the thermoelectric plate, which will create a thermo differential between the two sides and therefore will generate electricity. Next, the user will start moving his hand and the power will be generated since the magnets inside the coil will be moving and will generate an EMF. The generated power will go through to the boosting circuit. The boosting circuit have a transformer 1 to 100 ratio that will transform the power to 1.6 volts. The output of the booster will go through the battery or the ultra low power sensor, and it will power the system. This system is supposed to be run 24 hours throughout the day. Flowchart for the system. Flowchart for the system. As per any self-powered devices, it starts with contacting with the environment. This environment will be the human. The heat will be absorbed to the human hand and will go through the modules to create the differential in temperature and will generate the electricity. At the same time, it is assumed that the human will start moving the hand. This movement will generate the electricity as well through the electromagnetic generator. The power of these two sources will be combined in the boosting circuit. The boosting circuit will get the voltage to 1.6 coming from 100 millivolts. The output of the circuit will be connected to any sensor or microcontroller, since it will be a general harvesting device. The extra power not used to power up the sensor or the microcontroller will be stored in a supercapacitor or a battery. This extra power can be reserved for later use in case any source of the harvesting is out of the way. Therefore, the battery will come in and supply the power needed. Moving on to our test result. These three pictures represent the result of the system. The picture on the left is the final prototype for the system, where the system is powering on an LED with around 1.6 volts. The picture on the right bottom is the output of the harvested voltage without any boosting, which is around 106 millivolts. The top right is the system without the covering, and it's powering on the LED as well. Now for the testing data. The testing data will be separated into three sections, each section for each objective. Objective 1, heat harvesting. In order to harvest the heat, a differential in temperature has to be made between the plate of the module. The body will be the hot side and the ambient temperature will be the cold side. The AC is used to change the temperature, since the human body will be the same. A complete of 3 tests is done, and the average is shown in the table on the right. It is observed, the lower the temperature for the AC, the higher the output for the module, since there is a greater difference in temperature. As the temperature goes up, the output will go down. The next test for this objective is the different types of connection between the modules, since there are 8 modules to be used. In the case connecting all the modules in series, you will get the highest voltage but the lowest current, as well as for the highest resistance. As we change in the connection between the series and parallel, the different output is absorbed. and it's concluded that the best connection is 6 in series and 2 in parallel to give a sufficient current and voltage to be used for the harvesting circuit. The next test is for objective 2, the movement harvester. The factor that will be controlled in this test is the coil term, since it is a main factor for controlling the output of the electromagnetic generator. Assuming the magnet will be the same for all the testing, the terms will be the factor that we can control. It is observed from the table, the higher the number of terms, the higher the output for the movement harvester. Moving on to the frequency. The more frequent the user moves, the more power will be there. According to journal, 10 Hz is the maximum movement for the human. The testing is done on 1 Hz, 5 Hz, and 10 Hz, and observing that the 1 Hz is the lowest output and 10 is the maximum output. The last test is for the voltage boosting, where the main factor to be manipulated is the resistance of the harvesting circuit. The voltage boosting depends on the internal resistance. Since the higher the resistance is, the lower the voltage output. Since the efficiency of the circuit can be lowered with the increase of the resistance. The manipulation and the connection between the thermoelectric plates will modify the resistance of the circuit. The most efficient method has been observed to be the 6 in series and 2 in parallel, which will give 1.6 volt output. Conclusion. To conclude this presentation, this system is a self-powered device for general use, but for this project it will be used on the human hand to harvest the heat coming from the human body and the movement of the hand. A total of 5 tests are done. 2 tests for the heat harvesting and another 2 for the motion harvesting and 1 for the voltage boosting. The system works and gives an output of 1.6 volts, which is almost equivalent to a AAA battery.
This is the video demonstration for the self-powered device. The user will wear the device and it will start harvesting the power. It can be seen the LED is turning on slowly from the heat harvesting device. As the hand starts to move, the power of the LED will increase, since the 2 sources are combining together to power on the LED. The circuitry is covered with adhesive to make it waterproof. The output of the circuit will be 1.6 volts.